Hello, my name is Nirav Gujarathi. This is my presentation on the paper Visual Analytics for Multimodal Social Network Analysis, a design study with social scientists. So let's begin with the abstract. Social network analysis is a method for studying relationships between actors in a network. So a multimodal social network analysis (MSNA) is a type of SNA that focuses on networks where actors and relations belong to different types or modes. In this paper, the authors present a design study on how to use visual analytics tools to support MSNA. They developed visual representation called parallel node link bands and used it in evaluations with social scientist collaborators to gather feedback and insights on its usefulness and the potential of visual analytics for MSNA. Social scientists may want to investigate asymmetric relations in organizations with strict chains of command. Multimodal social networks are those where actors and relations belong to different types or modes. The authors devised a visual representation called PNLBs that splits nodes into separate bands. As I mentioned before, social network analysis (SNA) is a method for studying the relationships between actors in a network. Modern information technologies such as social media websites have made it possible for people to connect and relate in new ways, creating large and complex networks that require software support for analysis. Visual analytics is often used for this purpose, with several systems available that combine visual representations and network statistics to aid in SNA. However, in many real-world settings, networks consist of multiple types or modes or of nodes and edges, such as co-authorship networks that include authors, venues, journals, or organizational charts that include employees and departments. These multimodal social networks require specialized techniques for visualization and analysis. In this paper, the authors present a design study on the use of visual analytics for multimodal social network analysis through iterative process involving formative design and evaluation phases. They propose a visual analytics tool called MMGraph and provide insights on the challenges and potentials of MSNA. So what's the background here? Social networks are universal to the human condition. They can be used to model our relations to friends and relatives, our connections to groups and organizations, and the social structure of our neighborhood, state, or nation. Researchers have studied on these types of social networks using network theory and techniques through what is collectively known as social network analysis. Social networks are a fundamental aspect of human society and can be used to model relationships between individuals, connections, and the social structure of communities. Researchers use social network analysis (SNA) to study these networks and understand social phenomena such as spread of obesity through friendship and the formation of extremist groups and user interactions on social media. A multimodal graph is a graph that with vertices that can be partitioned into different types or modalities. The modality relation is defined using the notion of vertex type. This allows for the representation and analysis of networks and multiple types of vertices and edges. Multimodal social network analysis is a social network analysis in the context of multimodal social networks where actors can be partitioned into modes. Multimodal social network analysis enables the examination of a wide variety of questions beyond those possible with unimodal networks, such as the way people participate in events or affiliate with social organizations, or the role of institutions in co-authorship patterns. However, there are a few techniques for visualizing multimodal graphs, and a standard theoretical framework for analyzing multimodal social uh, networks has not been established. The authors present a design study on the use of visual analytics for multimodal social network analysis through iterative process involving formative design and evolution phases. They propose a visual analytics tool called MMGraph and provide insights on the challenges and potential of multimodal social network analysis. Overview. The study was intended to support our social scientist colleagues in performing multimodal social network analysis. The paper employed an exploratory and user-driven design process with the following stages: formative sketching, brainstorming, prototyping, and requirements gathering. It then progressively refined on their visual analytics tool based on domain expert feedback. The goal of the study was to use an exploratory and user-driven design process to help develop a visual analytics tool to support the multimodal social network analysis. The process involved formative sketching and prototyping, requirements gathering, and iterative tool development based on domain expert feedback, formative evaluation with 5 social scientists, iterative tool refinement, and summative evaluation using domain experts. The aim was to support social scientist colleagues performing an SNA, particularly in the context of multimodal networks, for which existing literature presents theoretical and analytical frameworks for two-mode networks but has not yet been fully expanded. The early design process for a visual analytics tool to support multimodal social network analysis involved brainstorming, sketching, and reviewing existing work in the domain. An early prototype was developed with a sample dataset and input from a social scientist collaborator, and specific contextualized questions that the social scientist might want to answer using the tool were derived. These questions help prioritize features to be implemented and served as test cases to verify the purpose of features in the initial prototype. However, it was challenging for domain experts to come up with such questions at this early stage in the design process. This phase of the study aimed to support social scientists in performing multimodal social network analysis. The researchers employed an exploratory and user-driven design process and recruited a social scientist with an interest in multimodal social network analysis as collaborator and co-author. They created an initial visual analytics tool for multimodal social network analysis called MMGraph, and which used GraphML format to load multimodal graphs and provided a compound network visualization with color coding to convey mode information. However, this visualization was found to be inappropriate for a multimodal social network analysis due to its high visual complexity and difficulty in distinguishing between within mode and between mode ties. As a result, the researchers added parallel node link bands to MMGraph, which partitioned the visual representation into separate bands where based on modes to minimize visual clutter while maintaining cohesiveness and allowing users to reorder the bands to expose different between mode networks. They also explored the design space of PNLBs, including the node and link representations, the layout of the bands, and interaction possibilities. Finally, they conducted a summative evaluation with domain experts to assess the utility of MMGraph and PNLB's representation for an SNA. The purpose of this part of the study was to evaluate a prototype implementation for multimodal social network analysis task. A qualitative study was conducted with 5 domain experts in social network analysis. They were asked to use the prototype tool to answer 4 multimodal social network analysis tasks using multimodal data set derived from funding data from the US National Science Foundation. The tasks include identifying the most successful principal investigator in terms of number of awards, finding principal investigators who have been awarded grants together, identifying program managers who often award grants to the same principal investigators, and finding projects that have been awarded more than 70 million and their commonalities. The results of the study showed that the prototype tool was effective in helping participants answer the tasks and that the parallel node link bands design was an appropriate visual representation for multimodal social network analysis. This study also identified areas for improvement, including adding more interaction and customization options and better support for handling large graphs. The goal of this part of the study was to develop a visual analytics tool for multimodal social network analysis with the help of a social scientist collaborator. The design process included early design, iterative tool development, formulative evaluation, and summative evaluation. During the early design phase, a low fidelity prototype was created using a simple dataset and input from social scientist collaborator. The iterative tool development phase resulted in the creation of MMGraph, a Java application with compound node link diagrams and parallel node link bands to visualize MSNA data. The formulative evaluation phase involved a qualitative study with 5 domain experts who provided feedback on the tool and its potential uses. Based on this feedback, the iterative tool refinement phase included the addition of features such as water level color glyphs and the ability to order, filter, and visualize nodes based on network metrics. The summative evaluation phase involved a second qualitative study with 6 domain experts who tested the feedback tool and provided further feedback. Overall, the studies found that the tool was useful for MSNA tasks and that the parallel node link bands were effective for visualizing MSNA data. The purpose of this phase of the research described in this text is to develop a visual analytics tool called MMGraph for multimodal social network analysis. MMGraph is a Java application built using the MMGraph is a Java application built using the Piccolo library and is designed to load multimodal graphs into the GraphML format. The tool was initially designed with a standard compound network visualization, but was later modified to include parallel node link bands to improve visual clarity and structure. PNLBs use visual node and link marks partitioned into separate bands based on modes and arrange the bands in parallel to maintain cohesiveness. The bands can be reordered to expose other between mode networks. During the iterative development process, MMGraph was evaluated through a qualitative study with domain experts and refined based on feedback received. In a final summative evaluation, MMGraph was found to be effective in supporting MSNA tasks and was appreciated by participants for its ability to encode node attributes and visualize multimodal network metrics. Participants also noted that MMGraph allows for a more structured and systematic approach to MSNA compared to traditional methods, which often start with a particular node and gradually expand the scope of the investigation. So the purpose of this research was to design and evaluate a multimodal social network analysis tool called MMGraph, which allows users to visualize and analyze multiple types of relationships modes within a single network. The authors conducted two qualitative evaluations of graph, one formative and one summative, using a dataset of funding data from the US National Science Foundation. The formative evaluation identified several weaknesses in graph and provided feedback for improving the tool, including the ability to use it with personal social networks, clustering nodes in compound views, streamlining the interface, and integrating traditional network metrics. The summative evaluation found that the improvements made to graph, including the ability to encode node attributes and use multimodal network metrics, were appreciated by users. It was also observed that the divide and conquer approach and the details on demand features of graph were beneficial for MSNA, and they allowed users to focus on between mode relationships and investigate within mode networks and node attributes on demand. Overall, the evaluation showed that graph is a useful tool for MSNA, allowing users to effectively analyze multimodal networks and make new insights. So, what are the conclusions? This paper presents a design study on the application of visual analytics to multimodal social network analysis. The resulting tool, called Graph, combines both a compound network visualization and a view using parallel node link bands. It provides effective structure for multimodal social network analysis and seamless integration of network metrics and visual representation. There are limitations to evaluation studies, including a small number of research participants and a lack of diversity in dataset used. The study was conducted in 5 phases, including initial design, iterative tool development, formulative evaluation, and a second iterative development phase, and a final summative evaluation. The study found that graph has several benefits for multimodal social network analysis, including an effective structure for multimodal social network analysis, a seamless integration of network metrics and visual representation, and divide and conquer and details on demand design strategies. However, the parallel node link bands technique is not universally effective, and there are limitations to the evaluation studies, such as mentioned, a small number of research participants and a lack of diversity in the datasets used. Further work could involve visual analytics of longitudinal multimodal networks and additional user studies with their own domain datasets. Thank you so much for viewing my presentation.